Welcome to this video on 3D trigonometry. Okay, so what we're going to do is we're going to find and solve right-angled triangles that are hidden within this box, this cuboid. All right, now we've got to be really careful when we do these problems that we break them down into 2D problems that we can work with. So let's take the first angle that we're required to find out, ABE. Okay, so it's the angle you make if you travel from the point A to the point B to the point E. So the first thing I'm going to do is to recreate just the relevant part of the cuboid that we're interested in. So for part A, I would do this. Okay, I would say that let's start over here. So for part A, I'm interested in this box here, okay, which is from E down to A and across to B. Okay, so that's the front of the box as we're viewing it. I'm just going to put the line in there. Okay, and I'm interested in the angle ABE. So I'm going to label the points as they are on the diagram. So I've taken this straight off the front of the box, A, B, E, all right? And I've drawn in the line where I can now see the angle that I want. So the angle is this one here, okay, which is the one that corresponds to the middle letter in the block of 3. Now I'm going to call this angle, just going to use X, okay, for the actual angle itself. It's easier to write X rather than repeatedly writing ABE. Now, using the information I have, if the height of the box is 40, then I know that this line AE is also 40. So I'm going to transfer that onto the diagram like that. Okay, and I already know that this length here is 22.5. Okay, so the question is, what trig ratio do I now need to use in this right-angled triangle that I've created? So it's from X, the 40 is opposite and the 22.5 is adjacent. So I can say that the tan of X, because it's opposite over adjacent, it's the tangent ratio. The tan of X is equal to the opposite over the adjacent. Okay, and therefore it follows that X is the inverse tangent of that. So underneath that I would write that X equals the inverse tangent of 40 over 22.5, and put that on the calculator. Make sure the calculator is set to degrees, and when you put that in, it should be in a set of brackets. Okay, and that will give you the value of X to, well, normally we would do 3 significant figures with most of these questions. So that equals to 3 significant figures, that comes to 60.6 degrees. Okay, 60.6 degrees to 3 significant figures. Okay. Now that was a relatively straightforward question because it was easy to extract the triangle off the front of the cuboid. Okay, now let's look at question B. Okay, question B, and it's asking us to find the angle ECA. So I'm going from the point E to the point C to the point A. Now I'll just sketch that in. It's really important that you can see a potential problem here. okay? Because in order to work that out, I need to know the distance across the floor diagonally, and I need to go down from E down to that point there, to the point C, and I need to recognize that this is a right angle on the floor of the cuboid. Okay, so if you imagine the right angle is actually going to be this angle in here and down there, that's the right angle that's I'm going to be looking at. But I need to find out what the length AC is first of all. Okay, so I'm going to have to do this in 2 stages, and it's best if you really do set this out fully. So let's consider first of all the triangle on the floor, if you like, ABC. Okay, and then we can find out the length of AC across the floor there, you see, and for that we would probably use Pythagoras theorem. So I'm going to sketch that first. So this is the line AC, okay. This is the 22.5, and this is the line that's 30, which is the length BC. So I need to label some points. So this is our A, this is B, and this is C. Okay, this is 30, and this is 22.5. Okay, so I want to know what this length is here, and I'm just going to call that length, let me just call it Y. Okay, so I'm going to say that using Pythagoras theorem, you see I don't need to use any trigonometry here, y squared is equal to 30 squared plus 22.5 squared. Okay, and if you put that on a calculator and square root it, you get y is the square root of that, and that comes out to be 37.5. Okay, so y equals 37.5 exactly, all right? So that's the square root of 30 squared plus 22.5 squared, okay, centimeters. So I now know the length of AC in this diagram here, okay, and I also know the length of EA. So what I'm now going to do is take this triangle out here, EAC, and recreate that. Okay, so this continues with part B here. So let's redraw that triangle, which has a height of 40. Okay, so it has a height of 40. That's from E to A. From A to C, I now know that's 37.5. Okay, and this is my line, my diagonal going from E down to C. So what I've now got is I've worked out the length of the line AC. So this is the point A, this is the point C, and I now know that that is 37.5 from the previous calculation. I know my right angle is here, and I know that I have my point E up here. Okay, and that the height of the cuboid is still, of course, 40. Okay, so I can now use this triangle, which is the one I've sketched here in yellow that's now looking at it face on, and I can work out the angle I need, which is the angle ECA. So I'm looking for this angle here, okay, and I'm just going to call this angle alpha. Okay, so I can now use trigonometry for this one. and I can say that the opposite over the adjacent again, so it's tangent. So the tangent of alpha is equal to the 40 over 37.5. And if I rearrange that, I can say that alpha is the inverse tangent of that fraction. Put that on the calculator and it will tell me what the angle alpha is, and I want that to say 3 significant figures. Okay, and that comes to 46.8 degrees. Okay, 46.8 degrees to 3 significant figures. Okay, so that's my full answer with all the necessary working out for part A and part B. Okay, and it's really important on a question like this that you show the working out, and really that you do these two-dimensional diagrams which you extract from the three-dimensional cuboid. Okay, we go on to part C now, where we've got to calculate the angle EMH. Okay, so let's go up here with that one. Okay, I'll do that in blue, so we've got each part in a different colour. Okay, so part C. And EMH, so let's identify those 3 points. So M is a midpoint, okay, E, M, and H is over here. Okay, now we're looking at an isosceles triangle on the top of the cuboid, because if M is in the middle, okay, as it tells me here, then it will make an isosceles triangle, you see. So what I'm going to do is extract that surface on the top and recreate it looking as if I was looking straight down on it from above. All right, so it's going to look like, let me just sketch this here. So I'm going to have this sort of box with 22.5, and across here it's going to be 40, okay, and then it's going to finish off like that. Okay, and in the midpoint, which is M here, I'm going to have my triangle that goes up to the midpoint and back down again, making an isosceles triangle inside the box. But I just need to be careful now to label the points correctly. So if you take that and tip it over to give you this version, this will be where I've put the H would be here, okay, the M is up here and the E is down here, and then I have the F up here and the G, okay, over here. So that's how I've reoriented the top surface of that cuboid. Okay, so what information can I add to that now? Well, I need to know the angle EMH, which is this angle here, okay? And this angle here is exactly twice the angle I'm going to get if I just drop straight down there, okay? Because that's an isosceles triangle. So if I can work out, if I just put another point here, I'm just going to call it Q, just for my own reference. That's now a right angle, okay? So I can work out one of those angles in there, which are both the same, okay? And I can do that because I know that this line here between Q and E is going to be exactly half of 30, because that's the midpoint of a line 30 long. So that's going to be 15. Okay, and I also know that the height of this triangle is going to be from M to Q. That's going to be the same as 22.5. Okay, 22.5 is the height. I'll just put it there, 22.5. Okay, so using right-angled trigonometry, I can see that to get that yellow angle, which I'm going to call, let's call that angle Z. Okay, so I can say that the now it'll be the opposite over the adjacent again. So the tan of Z, right, the tan of the angle Z would be 15, that's opposite, divided by the adjacent, which is this line here, 22.5. Okay, which means that Z is going to be the inverse tangent. So angle Z is equal to tan to the minus 1 of that fraction 15 over 22.5. Okay, now if I put that into the calculator, I get 33.7 degrees to 3 significant figures. Okay, 33.7 degrees to 3 SF. And if that's 33.7, then the angle I want, which is the angle EMH, it's going to simply be double that. Okay, EMH equals 2 times 33.7, which is equal to 67.4 degrees to 3 significant figures. Okay, so quite a lot of work involved in these problems. They're quite fun to do, but you really do need to take the time to extract the relevant two-dimensional triangles and work on those. I hope that was helpful. Take care.